So first of all, thank you all for being here. It's so great to see a lot of teachers. Who all is a teacher in the room? I can, by show of hands. Okay, fantastic. So I feel this is karma because I studied in India. I was always a backbencher, right? And now it's funny because I'm the one presenting and all the teachers are at the back. So there's a lot of karma going on right here. But I promised my teachers, even though I was a backbencher, I was paying attention. Most of the time that was true. So I hope you guys are as well. Especially, can everybody at the back hear me? Okay, perfect. All right, so I'm here to talk about really exciting things, at least exciting to me. I'm going to talk about personalization and adaptiveness for better learners. As you know, one of the biggest things that Andre talked about was scalability and assessment and all those things that Dr. Singh and the panels before that went before talked about. So you're going to see a lot of that repeated because it's so important here. So first of all, what is personalized learning, right? Everybody has a really different aspect to it. We saw in the previous panel itself, the 6 C's. Depending on your context, 6 C's could mean completely different things in a progressive school versus an Anganwadi. I also heard about, hey, what is the input for education? Is it to get students to pass their exams and get really pass the standardized exams and get to a place where you can get a job? Or is it to really learn the subject really, really well so they're better prepared and more confident for their life, right? So for everybody else, personalized learning could mean many, many things. But what is common for everybody is to know what personalized learning is not, right? So when you think about personalized learning or adaptive learning, you can speak to everybody, they'll give you a different answer of what they think it is. But uniformly, everybody will say, everybody will tell you what it's not, right? Everybody thinks of, it's not having the same learning plan for everybody. It's not having this planned sequence in which to teach the different components of your lesson one by one. It's not having the same method to teach to each component differently. It's not having a time-based approach rather than having a mastery-based approach. If you spend 10 hours on something, you're going to get it, right? It's not having static feedback and something that's not actionable. It's not just having these report cards that say, okay, here's 73% and that's it. Your child is a 73% and there's no action based upon it, right? So everybody agrees what it's not. And they're right, because this would, that kind of approach works well when you have all the children be the same, right? So I always look at this picture where you have different children, they have different strengths, and for a fair selection, everybody has to take the same exam. You're asking an elephant, a monkey, a penguin, a goat, a seal, a fish to all climb the same tree. Yes, it's fair, but everybody is different. So it would work if everybody learned at the same pace, right? It would work if every child was fully ready in that factory model that Andy talked about. They were ready to grasp each component when the system sequence deemed it was the right next step to take. If they felt after spending a certain amount of time, they would master each topic sufficiently, and whatever that means, right? If each topic was as interesting to the child as the next one. But we know that's not the case. Every child learns differently. Every child has an area of mastery that makes them different. In fact, it is those differences that cause the children to be strong in different other ways. Okay, so my apologies, I'm trigger happy. Let's see. So I thought about, what should a personalized adaptive system look like, right? So for me, and again, for other people, it's going to be different. It's going to be about learning the manner in which each child learns best. And you need to use that to design a personalized teaching mechanism for that child. At Square Panda, we've seen, and I'm going to show you an example later, when if you know a child is learning well through song, maybe saying A or A over and over again is not the right way to do it. Maybe we can create a song to show them the letters and help them learn the letter A or any other letter, right? Another idea behind personal assessment is the system should learn as the child is learning. So that means in a continuous and invisible fashion, you need to be assessing the child in different skills and using that assessment to create targeted, what we call interventions, methods to teach the child, and therefore inform the adults to see what's happening, right? So you always need a feedback loop. And finally, and I'm not going to create a very long checklist, so I kept it to 3 things. The third thing is you have to constantly adapt and adjust to the child's skill level. You have to stay in what my friend Veera calls, and I think all the neuroscientists call, the zone of proximal development. I had to talk to Veera about getting the initials right today. But basically, you have to stay in the zone of optimal development where the child is neither frustrated and neither bored. You have to constantly challenge the child in staying between things that they can find too easy, what they can achieve independently themselves, or what they'll be able to not get frustrated by, right? So you have to scaffold your approach. And for us at Square Panda, that has meant staying at the 70% to 90% accuracy in the games we present to them. And I'll show you examples later for that too. Okay, so if you build that personalized system, what you should get is a system that gives every student agency to explore and learn their own way. Whatever that means, you want to build a system that helps the child hold a sense of curiosity and exploration. Like I said, it should challenge the learner but not demoralize them. It allows them to skip over material if the system detects that they already know it, or they are likely to know it really, really quickly. It helps them repeat content that's not yet mastered but presents the same material in a different fashion. And that's why for me, my question to the previous panel about innovating ways to teach children was so critical, because, and the answer was great. Most of you said, well, we get the inspiration from the children themselves. And that's what we at Square Panda also try to do. We try to see what works. We do a lot of kid testing and we try to build it into our system. And finally, you should get a system which is the best hybrid of software and human, right? So you want a tool for the adults, teachers and parents to provide them reporting, data, suggestions to take action upon and allow expert human direction when needed. But other than that, that system should learn from the child and keep proposing methods that would work for them. So how do you do that, right? How do we do that with software, with technology, with algorithms, and so on and so forth? For us, we've broken it down into 4 key ingredients. You need to know what the child needs to learn, right? All you teachers, all you educators already know what is that map. So if you can create, I'm using the word map, you can use any other word you want. I try to keep it simple. So if you have a map of all the skills a child needs to learn, you know where they are, right? So you can then create an ability to assess the child on each of those skills at different levels, because the child's going to be learning those different skills over and over again. Veera talked about the 7 skills. She talked about spelling, vocabulary, phonological awareness, etc., etc. So you need the ability to assess the child on all those things at different levels. Then you need to know how to discern the solution that you propose, the learning mechanism, the intervention that you're providing the child, which of those is working for the child in front of them, right? What works for one child might not work for the other one. So you need to be really, you need to know what works for each child. And finally, not to take away the immense amount of work that curriculum needs to bring in, which is You need deep and thoughtfully designed curriculum that can progress a child through each skill, right? And you take all these ingredients and you feed them all into this pot, into this algorithm that will somehow magically transport the child to the right place at the right time. Think of it as teleportation in Star Trek, or the I'm showing my age a little bit, but in the new in all the science fiction you see, the person just teleports to a different area. So if you can take the child around, you can find the right spot on the map. You can do that if you have those 4 key ingredients set up. Okay, I think I'm too far from this forward. Before I dig in a bit deeper, there is a caveat, right? If you are rich, and this Andy had mentioned this in his chat as well. If you're rich enough, well, fine, you don't really need software. You don't really need anything. You can just, what I'm trying to say is, this is not necessarily a technology problem. The problem, you can throw money at the problem. You can hire an ideal army of qualified tutors. You could spend hours and rupees and dollars finding these people. But every time you discover a new unique way your child is different, the way your child learns or fails to learn, you will either need to find a new tutor or you'll need to find a tutor that adapts to that scenario, right? And historically, again, as Andy had said previously, this is certainly solvable. He knows from his own personal experience as well. If you can throw enough money to spare, you can find the right people to come and teach your child. But this is not scalable. This is not scalable at all. So that's why technology is the disruptor. This is what helps you learn and improve over time. So by the very nature, these personalization and adaptive algorithms that I was talking about, they provide a significant boost beyond the one-size-fits-all model, right? You can actually improve technology. It's easier to change the design of the technology you've created and therefore control the quality through better and better design. But it's harder to find the right person at the right time. Algorithms can also be made thanks to all the processing power we have at our disposal and the data scientists and engineers that we have at our disposal. You can learn from all the children over time. You can learn in aggregate, so you can find out what works for the overall population. You can also find out, okay, these type of children were struggling with learning rhyming. So what did they do to overcome that struggle with rhyming, right? So you can find out 50% of those children that were struggling with rhyming, they used method 1 to get past that. The next 25% used something else. So that gives you an idea of how to rank those interventions when it comes to the 101st child, right? Because you know, okay, there's a 50% chance that if a child is struggling with rhyming, you can try something else. And the algorithm, because now we have pretty much unlimited cloud space and processing power, you can learn about your own child too. It can be really personalized. You can find out what works for this child, what doesn't work for that child. So if you know, for example, by singing songs, etc., that works for 50% of the children to teach them about rhyming, but you also know the child you're looking at hates songs for some reason, well, even though it works 50% of the time, you might not want to use that. And you can do that with technology. So this is a high-level picture of what we built with the Square Panda system. We have a multi-sensory interface, 45 physical smart letters. We're going to increase that over time. And really, this is a chart. I hope everybody's had a chance to go outside and look at the games. Please play them. If you have questions, come to us. Come to the people with the nice yellow buttons, but also to Veera and myself. We are happy to take you through what we have. So what we've done is we've built many games. We have a library of intervention programs. We've built a lexicon. We have an analytics portal. We have a bunch of applications, keeping it really high level and simple right now. And through a tablet and our playset and our physical letters, that's how the serving of those applications happen. But in the middle of it all is our AI engine that provides real-time interactivity on the 7 areas of language skills, on the history of game usage, on the application of interventions, on the 7 areas of language learning: spelling, vocabulary, print, phonologics, phonics, comprehension, word recognition, etc. That's how we do it. And this allows, the engine that we've built allows us to really create a very unique individual learning path. Veera touched upon it in her talk, so I'm not going to spend that much time on it. But basically, you have an area where, you know, each color here represents a certain skill. So for instance, yellow could be letter recognition, blue could be phonologic, phonemic awareness, etc., right? So for each game, you could literally start anywhere. You could just use a game to assess where the child is at, and then you could start them off at game 7, because you've discovered that, you know, Johnny in this case needs to start at letter recognition, but then he needs to go to orange, which might be, you know, print awareness, and then goes to another print awareness game, and so on and so forth. With data, somebody else can look completely different. I apologize for all the skipping around, probably too trigger happy. Having said that, the cool thing about technology is this doesn't need to be set in stone. Even though I can create a learning path for every child, nothing needs to be set in stone. The real-time assessment per learner, that's coming up. New content is always coming up from my game team as well as Veera's team on the curriculums. So the learning path for every child it's possible to change it for everybody. And if you haven't tried it already, I would love for you to go out and try Square, which is our latest game. That's a meta game that sort of looks at learning as a whole. You'll see, you know, they say a picture is better than 1,000 words. A video or your own experience is probably 1,000,000 of those. So you should go try that out. So basically, every child's learning path will always be on this upward trajectory, right? And that's what we are trying to do. Just to showcase that. So essentially, a child is going to log in. They're going to play. They look at different letters. We understand the specific pattern of mistakes they made. What are the knowledge gaps? That goes to the cloud. It's hard to believe, but in real time, algorithms can actually assess what the child is doing and what they need to do next. And it can throw back game modules to ensure a constant learning progression for the child. It makes sure the child is in the zone of optimal learning. And then again back, you assess the child yet again, and it sort of throws them back to the next lesson. And that's how we do that. Like I said, please go outside and play our games. But here's I don't know if the video is coming up, but let's see. Any sound? Okay, there's no sound, but so essentially this is how Squareland looks. This child that's playing is not doing so well with the letter A, right? So the systems ask the child to identify the letter A. They keep missing it, no problem, okay. So what happens now, instead of us having a static gameplay experience where the child has to now do many things before intervention can happen, the system will detect that the child is not so strong at the letter A and immediately take them to a different part of the game. So instead of the child sticking around with the one size fits all, the game itself, we've designed it so that the game itself is now going to, oops. the game is going to take the child. This is supposed to be a song. I know you can't hear it. We'll have a song game. We can have other games as well. If all the letters are mastered, then great. We know then that we can take the child to a completely different part of the game that takes them to the next higher level learning, where they're looking at onset rhymes instead of trying to master other letters. And again, if you play this yourselves, you'll see this. Finally, not all the data and the personalized stuff happens through the system itself. It's completely customizable. And how do we take care of that is we have portals. So I specifically, because Andre was just here, so I took the liberty of drawing his data. He graciously plays the games themselves or does that. Hopefully he's not here. Okay, good. So this is how his chart looks like. So if there's a parent or some other adult in his life, they could basically look at it, and this system can then send suggestions to the adult to tell them what next to do with Andre. This is just a very static view of the report card. There's a whole portal which you can interact with. We are building out. We are not done. We've just begun. So there is many things to be done in our software. One cool thing that we are thinking about is how to take the algorithm one step further and not just churn that into invisible assessments and what the next gameplay should be, but also about sending push notifications to teachers or parents about, hey, what is the next thing that the child should be doing? So instead of it being very prescriptive or very invisible, actually really actively send out things to teachers and parents and say, hey, our system sees that your child is constantly confusing between the letter A and R, which in the US actually happens with 23% of the children, and I know that from our statistics. So if your child happens to be one, maybe you can do something at home, because learning doesn't really stop when you've turned Square Panda off or when you've stepped out of the classroom, right? It's at that age, it's an all-day, all-night affair. And that's all for my talk. Happy to take any questions before it gets too mathematical and puts people to sleep. Nandini, Dr. Nandini, Dr. Singh. So, great question, and that's something that certainly keeps me up all night. No sleeping pills, nothing, right? So, anecdotally, we've seen amazing stories. So, we have definitely gone into into schools that don't have all the facilities that some of the better schools have. For those who are interested, I could show a little. It's probably in my email somewhere, where there was this girl that was very low on confidence. We had the story where she played with Square Panda for a while. She was not a strong speller, but she played with it for a while. This was in Texas somewhere, right? The super speller girl, you know the one I'm talking about. So there was this girl who was not very good. She came back. And then one of our salespeople who act as consultative people who go there they sat with her and they saw what was happening, and they encouraged her to play one of our games, Lagoon, which is not a spelling game at all. Which is it's if you go outside and play, you'll see it's a very open-ended game. You can choose any letters you want. You can play any set of letters, and the character Chameleon will actually say whatever you've put up there, right? So if you put in, SNOO, right? It'll say snoo, even though that's not really a word, but there is still some phonological, learning from that, right? So she played Lagoon for a while, as was recommended. I cut off the screenshot, but there's a section in the portal that tells you for each child what next game is recommended. And what ended up happening is she, I'm gonna, I have to pull this up, but she basically started spelling really, really well because she was given the nudge. She was given the opportunity to not spell precisely what was being asked of her, and she started spelling words on her own. And there's this picture later on that we saw. She had a cape, and she was told she was a super speller. So she was a superhero who was a super speller, and it was a great all-around feeling, right? In addition, so that's a very anecdotal way of sort of saying things. In addition, teachers tell us how much things have improved. But also, Veera's team conducted a study in one of the schools. It's on our website as well. We've definitely seen improvements in different areas of education. One thing we haven't seen is, so we stratified our studies as well. We looked at children that before using Square Panda were at the top of the class, middle rung, third rung, fourth rung, etc. And we tried to stratify the learning to see which children actually improve. We didn't actually find that much improvement with the children that were already at the top of the class. But we did find much more improvements at Tier 3 and Tier 4, and a little bit of improvement for Tier 2, which is fine by us. A lot of people ask us, hey, why have you limited your play set to 8 letters? I'm sure a lot of you are also thinking of that. Well, my answer to that is if you have children that can spell 9-letter words without needing help, they should be doing something else. You should not behold them to playing our product. Set them free, let them do something which is more complex and sophisticated than 8 letters. But this is truly for early age literacy ideas. But happy to share data, happy to share more stories. If you go on our Facebook page, there are lots of teachers and parents that anecdotally tell us of what's happening. We've also found out anecdotally that parents and teachers with children that are on the spectrum, they've told us what kind of improvements they've seen in their children. There have been stories of children that wouldn't interact with anything, but if you put a Square Panda in front of them, they would do that for 2+ hours on the trot. That's pretty great. But we don't have any scientific proof yet because we are all working towards building curriculum and our algorithms and software at this point of time. So still early days, but good news so far. Mm-hmm. Yes. So right. So of course the best use is if it's 1-to-1, of course, right? But it's the same. I mean, I know I grew up here, so I know classrooms. I grew up in a class that had 60 children, so not even 30 or 40 children. I was one of 60. So I know how that works out. And even though I was a backbencher, I still managed to sort of do stuff. But in the US, you typically do have classes that are 30 to 40 children size classes. What ends up happening is if you can't afford, or if you don't have the financial ability to buy 30 iPads and so on, that's fine, because you can break children up into groups, and you can have them use Square Panda in a rotational basis. So a lot of teachers, again, inspiration comes from the students themselves. So what teachers end up doing is they will, group 1 will get Square Panda for 20 minutes, group 2, group 3, group 4, group 5 will be doing other things. And then, it's like a roulette. Everybody gets to use it at some point of time. Yes, so it is individual. So what they do is they allocate a certain amount of time per group, and they will come in and help the children set up, and then the children play together. So that makes my job a little bit harder, because sometimes 3 children will come together and spell the big words. So that's fine because it's much more important for them to learn rather than for me to get clean data, right? That's fine. For me, data is a tool to get to the right point, right? So I can look at those children before and after and see what's happening. But yes, our product is not compatible with smart boards. But again, we haven't built, no company builds everything upfront, right? So if we find that that's something that's needed, we'll certainly find that use case. But absolutely, I think so. In a group setting, you have children that collaborate, and teachers have, by the way, Dr. Singh told us that when the children play together on Square Panda, it really improves their communication skills. They play with each other. We've also been told, you had asked a question about multisensory in Veera's talk as well. So one thing that the teachers love to tell us is the following story, right? So if you have an app that's just the iPad or Android, students or children will just look at the tablet, and that's it. So you can be, Vani, and Vani's not going to look up. But if you're playing Square Panda, because there is this collaborative component, the letters are strewn around in this confused kind of manner, they have to look away from the screen to look at what we have. And what that enables the child to do is you say Vani, and boom, the response is going to happen. So we haven't had the time to do a scientific study about it, but we know that that's already a step up from what used to be. So yes, it's screen time, but it is hopefully educative and collaborative and communicative screen time. Anyone else? Okay.
Thanks, Dhruv, for another insightful talk.
Square Panda.